everyone. Last time we talked about sampling distribution. So this time we'll be looking into confidence interval. So confidence interval is used for um, giving inference or generalization for our sample data. So when we use our sample data to make generations about the unknown population, so we know that it's called inferential statistics. So the sample data help us to make an estimate of the population parameter. So we realize that the point estimate is most likely not the exact value of the population parameter, but close to it. So after calculating point estimates, we construct interval estimates. So we call that confidence interval. So in this specific lesson, we'll be able to learn to construct and interpret confidence intervals. So for the learning outcomes, find the confidence interval for population and mean using random samples, and calculate and interpret a V-based confidence interval for a population mean when the population standard deviation is known. Okay, so before we move forward, let's just revisit this specific statistical paradigm, which shows the components of the statistics that we perform with the data that we have. So previously, we talked about population and samples, and we discussed about probability. So previously, we focus on probability, which tells us what kinds of samples might arise from a known population. That's why we create rules and tell us the likelihood of different types of samples that might arise from a particular population. So we call that in our sample space. Okay. So, however, in most of the real world problems, reasoning from the population to the sample is not likely our goal. It we have we have data from a sample and we want to know what can be inferred about the population. So in this specific lecture, we'll focus on um, the statistical method for reasoning from the sample to the population, and that we call confidence interval. So we are now um, in our way for our topic inferential statistics. We're done with descriptive statistics, so we now are working with inferential statistics. So as you can see in the diagram, we have parameters, which are the variables that we have, or the data that we have, which allows us to conclude based on the data we get from our sample, which speaks about our population. So for statistical inference, this provides us methods for drawing conclusions about a population from a sample data. So the purpose of collecting data on a sample is not simply to have the data on that sample. So we researchers take the sample in order to infer or make generalizations with the data. So some conclusion about wider population represented by the sample. Okay, so you can see in the illustration, we collect data from a representative sample and make inference about the population. So very timely now that we'll be having our election, from May. So you can see survey results about the preferential candidates of the Philippines. So based on that, they just get sample that specific company just survey sample in the population, in the entire population of the Philippines or the voting public in the Philippines. So that's around just 1,000. Okay. And then they would want to like make inference that uh, based on the data they get, maybe this candidate will be from rank 1 to 10 or 10 to 14, etc. So they make generalizations based on the data they get from the sample. Okay? So that's statistical inference. As mentioned last time, that you cannot entirely get the data of a population. So you just get sample from it and make and use that data to speak about the population. So we talk about confidence interval. Okay. So for confidence interval, okay, it just provides um, it provides a range of values, okay, constructed from sample data within um, which the true population parameter is likely to fall. It offers a more informative estimate than a single point estimate by quantifying uncertainty. So say for example, um, in CCIS, we wanted to survey and get the um, average height of individuals or students. So if we just look into the uh, mean for that specific point estimate, when if we get a sample from 800 students, we just get around 10 samples, we can have, say, for example, a mean of 5.5. And that specific point estimate does not maybe it's far from the population parameter or not. Okay? So that's why we have an interval. So we have confidence interval, which means, say, we have 95% that we are 95% that the mean speaks about the population parameter. So that's why we have an interval. So it just gives us confidence about the parameter or the estimate that we have in quantifying our um, data. Okay, so that's basically confidence interval. So the same is true when you have the survey. If you're watching the televisions, they say that there's a plus in plus two, plus four, no, minus or minus or plus two, no, to the data given. So meaning that's the range of values, which speaks about the true mean of the population. So that's how confidence interval works. Okay. So why do we need to use uh, confidence intervals? Okay. Basically, we want to use confidence interval to perform a statistical inference. Okay. Because they acknowledge the inherent uncertainty in estimating population parameters from the sample data. It is actually widely used in diverse fields to make informed decisions based on incomplete information. That's why we use confidence intervals. So when we speak about confidence intervals, these are the key components that we will be looking at. Okay, we will look at the sample means. So we already have our sampling distribution. Okay. So we know that sample mean that speaks about the population mean. We also look into the standard error, so which represents the standard deviation of the population and the square root of n if we take samples. No? So the number n there represents the number of samples we get from the population. Next is the confidence level. So here we have, say, 95%, 99%, 68%, 70%. That depends on the confidence level that you'd like to achieve. So a level of certainty about the true value of your mean in your confidence interval. Okay, so there are already what do you call this? There are already uh, most used confidence level like 90, 95, 98, 99. Okay? In most research, we use this confidence interval. And lastly, we have our critical value, which speaks also about the confidence level that we use. Okay. So later on, we compute for the confidence, the margin of error, I should say, and we look into the critical value or the Z. So we standardize the value so that we will know the actual portion uh, for our confidence interval. Okay. Next. So let's just look into some terminologies. Kulang ng class. Again, so just to review you, population is the entire group of interest. So example a while ago is the students in the entire CCIS. So we consider the 800 students of CCIS as the population. So the sample is a subset of the population used for analysis. So as mentioned a while ago, say we get 10 students and with their heights, the 10 students are the sample we get from the population. So for the statistical inference, it aims to draw conclusions about the population based on the sample data that we get from the samples. Okay. Next would be the sample mean. So the sample mean is represented by, it's actually represented by X bar. So it's represented by X bar. It's just the average of the sample data. And the sample standard deviation, which represented by S, measures the variability within the sample. So already know the purpose of the mean and the standard deviation as we have talked about that in our previous lessons. Okay. So these statistics are used to estimate, again, this is used to estimate the corresponding population parameters, okay, and the understanding of their properties is necessary. So for the standard error, so standard error, you see this when we compute for our sampling distribution, no? In the sampling distribution. Okay. So the standard error, which is just the representation of the population standard deviation over the square root of n, represents the standard deviation of the sampling distribution of the sample mean, which is crucial for constructing confidence intervals. So knowing now these terminologies, we can be look we are confident that we can compute for the confidence interval that we have. So let's examine each of the components for the next slide. So there are simple conditions for inference about a mean. Okay? So these are the requirements needed before making inference about the population mean. First, we have the sample mean must be randomly selected. Again, it should be unbiased. You select your samples randomly. Okay. Next would be the variable of interest must have a normal distribution. Again, we focus on looking into the variable that is should be normally distributed. So most likely, samples that is 30 and above, represents normal distribution. So kapag below 30, yung samples, it will not likely result to a normally distributed sample, okay, or data, I should say. Next would be the population mean is unknown. It means it should be unknown because we want to infer about this data. Okay. But of course, if it's unknown, if the mean of the population is unknown, syempre hindi natin alam kasi nga we cannot get the data for the entire population. Okay. But we can compute for the standard deviation of the variable, of the population mean when it should be no. So having said that, let's now look into the confidence intervals for a single population mean with known population standard deviation. So the formula for confidence interval is x bar, or the mean, the sample mean, plus minus the margin of error. Okay, plus minus the margin of error. So the margin of error here represents the critical value. So we have the Z value, that's the critical value, multiplied the standard error, or the sample mean standard deviation. Okay, so this, you see the format. Okay, confidence interval is equal to the sample mean, or x bar, plus and minus the margin of error. So in this specific um, formula or format, there should be an upper limit that's plus, and the lower limit which represent the minus. Okay, so let's try to look into each of the components of the format for the confidence interval for a single population mean with a known population standard deviation. So how do we calculate the confidence interval? First is we wanted to determine the confidence level. Okay. So basically these are yung 90%, 95%, and 99%. This corresponds to the different critical value, or the Z value that we have. Okay? As I've mentioned a while ago, this confidence level represents to a critical value, or the Z in our standard Z table. So the choice of the confidence level depends on the desired balance between the position and certainty, where higher levels result in a wider intervals. Okay? So in finding the critical value, you need to have the Z-score that corresponds to the desired confidence level and found using the Z table. Okay? Next would be to calculate the margin of error. So the margin of error is equal to Z, or the critical value, times the population standard deviation over square root of 1. And then lastly, you can now construct the confidence level based on the given format in the previous slide. So we have your lower bound, which is x bar, for the sample mean minus the margin of error, and the upper bound, which is equal to the sample mean plus the margin of error. So now this now gives us a range which the true population range is expected to exist. It's no longer a single value for the point estimate, but a range of value to speak about the true population range that exists. Okay? So this is the process in calculating the confidence interval. So again, I'd like to illustrate to you how we get the confidence, the Z-score in a given confidence interval. Again, allow me to draw a curve, okay, a normally distributed one. Okay, so say we'd like to look into the area. Remember that the area under the curve is equal to 1. Okay, so we have here in our formula, so that's 1. That's the entire area of the curve. We just like to subtract it to the confidence level that we want to have. So that's, say, assuming we wanted to have 95% here. So meaning this is the 95% of the proportion, and we are left with the left tail and the equal the right tail and the left tail with be divided into two. So that's why we have here 2. Okay. So for the entire area, um, we get the value. Okay. So this represents the formula in getting the Z score. Okay. Yeah. So example, if we want the Z score for 95% confidence interval, again, so we have here 0.95 plus 1 minus 0.95 over 2, which is basically just 0.975. So we use this value, no, and look into our Z table, and we look for the closest cumulative area to the left for the Z value. So if we use the Z table, we see that it's actually 1.96. Okay, 1.96. Yung 0.75. So it should be the closest value. So you refer to the Z table and look into the actual critical value of the Z. Okay, yeah. So that's how we compute for the Z score. Okay, so you have to use this formula, confidence level plus 1 minus the confidence level over 2. Okay, an exercise here. Okay, so you find the Z score for the following confidence levels. So again, for 98%, so we use the same formula. Okay, so this is 0.98 plus 1 minus 0.98 over 2, which is equal to, so let's compute for it. So basically, if you have 0.98, I will just use my calculator here. So that's 1 minus 0.98 plus 0.02 divided by 2. Okay, that's 0.01. So that means plus 0.98. So that's equal to 0.99. Okay, 0.99. So if you look into the Z table for this 0.99, which is referred to, if that's 99% closest value, that's actually 2.4. I know it's 2.23. The Z is 2.23. Okay, so let's check and verify whether you get the same value for a 99%, a 98% confidence interval. Okay, so that's point. Okay, so for the rest of the percentage, okay, you have to um work with it. It's 2 point, it's 2.30. This should be 2.33 based on the standard Z report. For the rest, 93%, 85% compute for the Z score. So we have here the margin of error, which again, one of the components in computing for the confidence interval. So the margin of error depends confidence that is required for the estimation. Okay? So you can see here the formula for the margin of error, which is margin of error. Okay? The margin of error nasa taas. Yeah. The margin of error is equal to Z, that's the critical value, times the population standard deviation over the square root of n. So Z here represents the critical value, the sigma here represents the population standard deviation, and n is the sample size we get from the population. So you actually have here some commonly used multipliers for the critical value. So we have 99, if we have 99.7 confidence, level of confidence or confidence level, you have a 3.0 for the critical value. For 99%, you have 2.58 or 2.56 critical value, and so on and so forth. So let's have here an example. A researcher wants to estimate the average time students spend on social media per day. He collects a random sample of 100 students and the sample mean of 2.5 hours. And the sample standard deviation, or we say the population standard deviation, is 1.5 hours. And he wants to construct a 95% confidence interval. So again, let's just compute first for the margin of error. So we know that the confidence level, no, of 95%, they or the critical value is 1.96. We know that the population standard deviation is 1.5 hours and n is 100. So to compute for the margin of error, we just use for the given formula above. So let's just, so we have here the Z or the critical value. So that's 1.96 multiplied by 1.5 over the square root of 100. So if we have that, we actually have 0.294 as value or margin of error. Okay. So we can now make use of this to compute for the confidence interval. Okay. So please verify and check whether it's really 2.94, 0.294, I should say. So that's 1.5 divided by the square root of 100. So that's 0.15 times 1.96. Okay, it's 0.294. So that's how you compute for the margin of error. Okay, now construct the confidence interval. So we now know the margin of error. Okay, and we just use the sample mean and plus minus the margin of error. So for the confidence interval, okay, we have here the sample mean, okay, plus and minus the margin of error. So we know that the sample mean is 2.5, okay, and we know that our um, margin of error is 0.29 or 0.294. Okay, so we just use that. So for the upper limit, so this is how it should be written. For the lower limit, 2.5 minus 0.29, so that's 2.21 hours. Okay, and for the upper limit, that's 2.5 plus 0.29, so that's 2.79. Okay, so how do we now interpret these values? So based on the sample of 100 students, so this is how you write it. Based on the 100 students, sample students, the researcher is 95% confident that the true average, okay, time all students spend on social media per day is between 2.21 and the 2.79 hours. Again, so this now gives you the confidence interval, which the range of values where the true population mean, is expected to lie. Okay, so we have a range of values. So that's how we construct the confidence interval and how we interpret the results. Okay, so let's have more examples to illustrate confidence interval. Let's have an example. Suppose scores on exams in statistics are normally distributed with a known population mean and a population standard deviation of 3 points. A random sample of 36 scores is taken and a sample mean of 68 points. So here are the following tasks that we'd like to solve. First, find the confidence interval for the mean exam score of yung 90% confidence interval. And then interpret the confidence interval. And is it reasonable to conclude that the mean exam score for all exams is 70%, or 70, I should say. Okay. So first thing is we want to list down the given or the given data that we have in our problem. So the confidence level is equal to, sorry, is equal to 90%. Mean or the sample mean is 68 points. Our population standard deviation is points. Okay. So let's compute first for our Z. So or Z. So for Z, again, we use C plus 1 minus C over 2. So this is 0.90 confidence level plus 1 minus 0.90 over 2. So basically, this is equal to, when you compute for that, it's equal to 0.95. Okay. So let's now look for 0.95 in our Z table, in the closest value. You can see that Z there, Z there is equal to 1.64 or 1.645. Okay? 1.64 or 1.645. Okay? So you take the average just in case parehas sila ng value dun sa Z table. Okay. So we'll now compute for the standard error. Okay. So for the standard error, so this is uh, the square root of the sigma, I can say, over the square root of n. So we have here the value. What's our population standard deviation? So our population standard deviation, yeah, population standard deviation is equal to 3 over the square root of 36. 36 yung score. Okay, 36, which is equal to, calculator tayo. Calculator tayo. Um, so while 3 divided by the square root of 36, it's 0.5. So this is 0.5. So we can now compute for our confidence interval, which is equal to the x bar plus minus the margin of error. So for the lower limit, lower limit is equal to the mean, which is 68 plus minus the z is 1.645 times 0.5. So it's equal to, so pag ginumpit nyo dyan, it's equal to 68 point, check that, so 1.645 times 0.5 plus 68, so that's 68.82 for the lower limit. For the upper limit, okay, 68 plus 0.5, so that's 68 point, I'm sorry, yan yung plus pala to. So this is minus. Compute natin ulit. 68 minus 0.5. So that's 67 point, come again. 68 minus 1.645 times 0.5. So that's 67. So this should be 67.17 or 67.18. Okay. For the upper limit, so this is 68 plus 1.645 times 0.5 times 0.5, which is equal to 68.80. So that's now the confidence interval for the problem. So let's answer the question. So let's interpret the result. So that's number 2. So we're now done with computing for the confidence interval. Ito na siya. So we now are tasked to interpret the confidence interval. So we can say that we are 90% confident, confident, okay, confident that the mean exam score, that the mean exam score is between 67.18 points and 68.82, 68.82 points. So that's how we interpret the result of the computation. Next question is it reasonable to conclude that the mean exam score for all exams is 70? So basically, we have mentioned that the confidence interval is the range of value when we are 90% confident of it, meaning there's just 10% of uncertainty, but the true population mean lies between 67.18 points and 68.82. So mababa yung percentage. So we cannot conclude that it's reasonable it's not reasonable to conclude that the Indian exam score is 70 points because 70 points it's outside the confidence interval which is 67.18 and 68.82. So yun yung lang, may 10% chance lang na above or below the given confidence interval. So it's unlikely, pero syempre 10% is still 10%, so meron pa rin namang 10%. So that's how we interpret the results. Okay. The last example to compute.